All right, guys, I'm going to talk to you about density today. We're going to take the density of this solid, it's just blue clay, and we're going to take it just as it is, and then we're going to take the density again after we split it in half. Okay, so real quick, formula for density. You'll just have to roll with this, so because everything's backwards, I had to write it on one side and then show you this way, so that way it shows backwards. Density equals mass over volume, or M over V. And what I really like about this formula, I think it's kind of fun, because to me, it looks like a heart. Density equals heart, or mass over volume, M over V. So just some information about density. The density units are either in grams per milliliter or in grams per centimeter cubed, and that's because we take the mass and we measure that in grams, and then the volume, depending on how we take the volume, because we learned there's many different ways to take volume, it will either be in milliliters or it will be in centimeters cubed. Okay, so for mass, we always use a balance, and we will measure that in grams. And then for volume, you have three choices that we learned about. You could either do liquid displacement, which would be in milliliters. You can do length times width times height. Volume equals length times width times height. That would be in centimeters cubed, because remember, you're taking 3 units. And then the last one that we learned about, that I kind of let you guys try to figure out, is the cylinder. The volume of a cylinder equals pi times r squared times height. Pi r squared times height. And that also would be in centimeters cubed. Okay. So this is a balance. This is what our balances look like. And the only thing you have to do is you have to make sure it's on a solid platform. Don't put it on the book or anything. Put it flat, solid. And then you just turn it on. And I'm actually going to leave it down because otherwise it doesn't calibrate correctly. It will come up as 0. Now again, it's not going to show you, but this is where it will come up and say 0. So when I set it back down, it should go to 0. And then you just take your solid and you place it on there. Okay, for this one, my density, or I'm sorry, my mass equals 112.7 grams. I've written that down. Mass equals 112.7 grams. Okay, going to take it off. Going to turn the balance off for a minute because I don't need it. And then I'm going to take the volume. Since this is, I know it's kind of strange because it's clay, but we're just going to pretend this is a perfect solid, so we're going to be able to do length times width times height. I've got my ruler here and I'm going to measure in centimeters. So I've got a volume that equals, starting at the 0, 4.5 centimeters times, and I'm flipping it over to do the other side, 4 centimeters, so 4.5 centimeters times 4 centimeters times, and then I need to do the height. And that's going to be, I've done the length, I've done the width, I've done the height, and the height is going to be 3 centimeters. Okay, you just have to make sure that you get all 3 dimensions, so like length, width, and height. Okay, just make sure you measure all 3. So here are my numbers. My mass equals 112.7 grams. My volume is 4.5 centimeters times 4 centimeters times 3 centimeters. I'm going to take my calculator and I'm going to do the math. 4.5 times 4 times 3 equals 54 centimeters cubed. And again, my mass, it did not, obviously I don't have to do any math with that, so I just leave it at 112.7 grams. So here so far is my density. Density equals mass over volume, and that is 112.7 grams over 54 centimeters cubed. I'm going to divide that, so I'm just taking my mass divided by my volume, which is 112.7 divided by 54. Awesome. That gives me 2.09 grams per centimeters cubed. 2.09 grams per centimeters cubed. Okay, so this is my first one. So I'm putting just a number 1 above that because this is the first time I'm taking that density. I want to do it again. Now this time I want to split the solid in half and see what happens. Okay, so got my solid, splitting it in half. Okay, I'm gonna make sure it's ready to be measured. I think this one's a little bit better, so I'm going to take and do the density for this now. Get my paper so that way I can write the density on it. Okay. Density equals M over V. My mass for my new object, split in half, taking the mass. 59.3 grams. Divide that by my volume, and I need to be able to do length times width times height. Length, 3 centimeters. Times width, 3.5 centimeters. Times height. Which is, so I'm making sure, triple checking that I've done my length. My length is very short this time now that I've cut this in half. Times my width, which by the way did not change. Times my height, which also did not change, which is still, oh, it's probably 4. I'm going to change 3.5 to 4. That's kind of close. And then what I did change is now 2.5 centimeters. Okay, so just to refresh, my length did not change because I didn't break it at that point. I did not split that piece of clay there. So it's still 3. My height did not change. It is still 4. But what was, or I'm sorry, my height is still 4. My width is still 4. My height has changed. It went from 4.5 to 2.5. Okay, these numbers are still the same because that's not where I split the clay. Here's where I split the clay, so this is the only number that has changed for my volume. going to divide that by 59.3 grams. Get out my calculator. So that's going to be 59.3 grams divided by 3 times 4 times 2.5, which equals 30. That's going to be centimeters cubed. 59.3 divided by 30 centimeters cubed equals about 2.0. Okay, and that the measurement or the unit would be gram per centimeter cubed. Okay, so this is the second time I'm doing this, and I want you to notice something. So the first time I took the density, it equaled 2.09 grams per centimeters cubed. This time it equaled 2.0 grams per centimeters cubed. Hopefully you're noticing that these are really, really similar. The lesson here for you to learn is density does not matter the size or the shape of the object. The only thing that matters is what it is made of. So density does not change with size or shape. It just changes with what the object is made of. Each and every element has its own special density, and it does not matter how much you use of it, it will always be the same. Now again, you can, say, well, Miss Lowe, you probably were off, maybe because I did my math and I rounded things to the nearest tenth, so that way, I didn't have incredibly long numbers, and because I rounded, that might be why I was 0.09 off, but it was pretty close. So again, density does not matter the size or the shape. All that matters is what the object is made of.